In this video, we'll show how to calculate the row-reduced echelon form of any matrix with the TI-84 calculator. So the process that your calculator is going to use is the process of Gaussian elimination. Usually we have this process when we're dealing with an augmented matrix, and then we're trying to create row-reduced echelon form. What we can do to do that is we can use multiplying a row by a constant, swapping rows of your matrix, or replacing a row with two rows added together, possibly multiplied by constants. Now, your calculator is going to do all of that in the background with the RREF. So let's say we want to use Gaussian elimination and force row-reduced echelon form of this matrix. 2, -5, -28, 3, 1, 26. So if I do that, the first thing that I have to do is I have to input the matrix. And the way that that happens is that I go into the matrix menu. So I hit second and then the matrix menu, and then I'll edit. I'm going to edit matrix A. So I'm going to edit number 1 or edit matrix A. My matrix A had 2 rows and 3 columns, so it was a 2 by 3 matrix. The particular matrix that I wanted to input was the matrix which had 2 as the 1 entry, -5 as the 1 entry, -28 as the 1 entry, and then in the second row, 3, 1, 26. Now I have the matrix A that I want. Now I go back to the home screen by hitting second and then quit. Now I would like to put this matrix in row-reduced echelon form. So I go back into the matrix menu, second matrix, and then I go over to the math, and I scroll all the way down. It's actually a little bit easier to scroll up, to push the up arrow, until we see RREF. So I hit enter on that, and then I go back into the matrix menu, and in the names section, select the matrix A, because that's the one I want to put into row-reduced echelon form. Once I hit that, I end my parentheses by hitting a parentheses on the right-hand side, and then just hit enter. When I do that, I get the augmented matrix 106 as the first row, 018 as the second row. So that's how we can put any matrix into row-reduced echelon form. Just take RREF of matrix A. Now, this matrix had 2 rows and 3 columns. Here's another matrix that has 3 rows and 4 columns, and we could have done the same with this one. I'll call this one matrix B and put that into the calculator. Now, I've actually already put this matrix into the calculator. You can see that by going into the matrix menu, scrolling over to edit, and then clicking on matrix B and seeing that I have the right entries. Another way to see that I have the right matrix input is by going into the matrix menu and then just clicking on the number 2 or scrolling down to the number 2 and hit enter, and then hit enter and see that my matrix comes out the way I want it to. So now what I can do to make this into row-reduced echelon form is I go back into the matrix menu, again, second, and then this button here. I scroll over to math. Again, you can either go down a lot or up just a few times. Hit RREF, and then go back into the matrix menu and select matrix B. Into my parentheses, hit enter, and that is the row reduced echelon form of this matrix here. Now, both matrices that I used had a really nice row reduced echelon form where we had the identity in the first square, but obviously this would work if we had uglier row reduced echelon forms as well. Just RREF of whatever matrix I want to take the row reduced echelon form of. So that's how to calculate row reduced echelon form with the TI-84 calculator. Now there's one other way to do Gaussian elimination as well on our calculator, and that's to do step by step. So obviously I put this matrix in row reduced echelon form, or I found the row reduced echelon form of that matrix. But we could have also done Gaussian elimination in a step-by-step manner as well. So let's do that with our matrix A. So let's start with matrix A here, and in a step-by-step manner, let's try to create the row reduced echelon form of this. So normally in Gaussian elimination, you would put a pivot position where we see this 2. That means I'll make this 2 into a 1. That means I want to multiply that first row by a 1/2 or a 0.5. The way I do that is I go back into the matrix menu and I go over to math. These last 4 lines in the math menu are the operations of swapping rows, adding rows together, multiplying rows by a scalar, and then multiplying a row by a scalar and adding it to another row. So the first thing I'll do is I will multiply my row 1 by the scalar of 1/2. So I'll take 1/2. So I take times row. First thing I go is 1/2 or 0.5. And then I'd hit comma. And then I'd go back into the matrix menu for matrix A. Now I want to multiply row 1 by that 1/2. So in the last entry, I put the number 1. And then what I'm going to do is I'm going to, since I have A in this, A as this value, every time where I do a row operation, I'm going to create a new matrix A. And I'm going to store that. So I'll hit the STO arrow. I'll store that in my matrix A. So I'm replacing this one with 1/2 times the first row of that one. So that is my new matrix A. And if I want to confirm that, then I can go back into the matrix menu and hit enter. And now notice that what used to be my old matrix now is this matrix. Okay. Well, now what I would do is I would get zeros below that pivot position of 1. So in that case, back to the matrix menu, math, I'm going to multiply a row and add a row. So here's what I do. I need to get a 0 there. So I would multiply this first row by a -3. And then we have to declare what matrix we're using. we'll use this matrix, which is our new A. Now, there's going to be two rows that I have to input now. So what I'm going to do is I am going to multiply row 1 by that -3 and add it to row 2. Then I'll store, again, that's just the store button here, that new matrix as my new matrix A. So this means that I take -3 times row 1 and add it to row 2 of matrix A. And there we go. We get a 0 right below there. At this point, I'd want to make this 8.5. We see that that is a pivot position. So what we would do now is we would multiply this second row by a 1 over 8.5. Again, back into the matrix math menu. I'm going to multiply 1 over 8.5 in matrix A, and I'm going to multiply that by the second row. Store that as a new matrix A, and I'll be set. There you go. Now I've made that into a pivot position of 1. Lastly, I'd want to make a 0 above this 1. So that means I need to multiply row 2 by a positive 2.5 and add it to row 1. So again, back into the matrix math menu. I'm going to do the multiply and then add. I'm going to multiply 2.5 in my new matrix A. I keep storing it so that it updates it every time. So I'm going to multiply, I'm going to multiply row 2 and add it to row 1. And then I'll store that in my new matrix, which will be A again. So 2.5 times 1 plus this should give me a 0. And sure enough, I get that. Notice that this was exactly the same thing I got way back earlier when I row reduced A to begin with. So if you want to do it in one fell swoop, just take RREF of our matrix A. If you want to do each individual step of Gaussian elimination, you can do it using this method. Just multiply a row, add it, multiply a row by a constant, multiply a row, add it. And obviously the other operations, if we do need a row swap, you just row swap. Let me go ahead and say we're going to swap rows 1 and 2 of matrix A, and you'll see what happens when I do that. Those flip. I didn't store that because I don't want to keep this one, but there we go. So my matrix A is still this as it sits in the calculator. And then you could have also just simply added the two rows together as well. If you want to add two rows without doing a multiplication, then all you do is say in matrix A, we want to add row 1 to row 2. This is adding row 1 to row 2. If I did 2, 1, I'd add row 2 to row 1. Adding row 1 to row 2, and replacing row 2 would give me this. All right. Notice that's from the original here. So those are all of the Gaussian elimination steps. If you want to do it in a step-by-step process, obviously just doing the RREF is a lot faster. But in any case, I ended up with the row reduced echelon form of 106018. If you wanted to do this one step by step, you could. It would just take a lot longer time than doing this 2x3 matrix. 3x4 matrix, we'd have a lot more steps on the Gaussian elimination. So there we go. That's how to use your calculator to put a matrix or give the row reduced echelon form of the matrix. We did that using RREF and then also using the step-by-step tools of Gaussian elimination, which are programmed into your calculator.